Students, today we will discuss about some applications of differential equation. So today topic is applications of differential equation. So here in our topic, the first application is exponential growth. Okay. So for this exponential growth, the governing differential equation dE is given by dy by dt is equal to ky. So ky, yeah. So ky. So where y of t being any quantity that increases with time t. So see here in this differential equation. So what is given here is a first order differential equation. Here y is unknown function. Okay, so here you can say y is unknown function. Here what they say, y of t as a function of t is a quantity that is increasing with time, that increases with time. So here from this differential equation you can see that the rate of change of that quantity is proportional to the quantity present. Okay, if you assume y of t as a population, because you know the population is almost increasing everywhere. So if you assume y of t is the population of a country, then we can say the rate of growth of population, y is proportional to the number of population present, I can say. The number of population present. So we know that the population is changing based on the current population. Okay. So for example, the population here in the sense it can be anything. For example, if you consider the corona cases today, uh, I'm speaking around the world. Okay, so today there are 100,000 corona cases all around the world. 100,000 corona cases all around the world. Okay, suppose I'm asking what will be the number of people with corona after 7 days. For example, maybe 9. Okay, so on 9th December, if I ask, okay, 9th December 2021, if I ask what will be the population after 6 or 7 days, then we can say approximately, but how to say? But we know that the number of cases on 9th December will be based on the current number of cases. Okay, how many people are affected right now will be the input for the future infection. Okay, so that we can say. In the same manner, if you want to calculate the population, we can predict. Okay, we can just predict the population of a country. So population of maybe some Bahrain, population of Bahrain. If I say population of Bahrain is around 4 million, just for example, 4 million in the year 2020, in 2020. If I ask what will be the population of Bergheim in the year 2050, just for an example, okay, if I ask what will be the population during the year 2050, then we can say that population in the year 2050 will be based on the current population, okay. So that is what I have written in terms of your differential equation. So see here, the rate of change of this quantity y will be based on the current scenario, the current population. So that is what I have written here. So we will discuss this differential equation in detail by taking one example. Okay. So example. Really solving the problem is very easy. Huh? It's very easy. So example. A culture has y naught number of bacteria at time t equal to 1 hour. The number of bacteria is measured to be 1.5 y naught. If the rate of growth is proportional to the number of bacteria present, determine the time necessary for the number of bacteria to triple. Okay, so see the question. A culture has y naught number of bacteria at time t equal to 1 hour. The number of bacteria is measured to be 1.5 y naught. If the rate of growth is proportional to the number of bacteria present, to determine the time necessary for the number of bacteria to triple. Okay, so this is the question. So whenever they give this type of question, so you must know how to convert the given information in terms of condition. Okay, so for example, if you want to do this question under the above differential equation, you can see here there are two variables y and t. Y is dependent variable and t is independent variable, or you can say y denotes the number of population at some time t, and t is it's time, small t stands for time. So see here, even I can say this is time, and y that denotes the number, so time t. So see the first sentence. A culture has y naught number of bacteria. So here they don't say anything. Okay, so you can take initially, initially in the sense when t is 0, how many bacteria? There are y naught number of bacteria. So see the first condition, when t is equal to 0, the number of bacteria is y naught. So see the first sentence, how I am converting to a condition. So when time is 0, okay, the number of bacteria is y naught. At time, see the next sentence, when time is 1 hour, that is when small t is 1, the number of bacteria is measured to be 1.5 y naught. So it is 1.5 y naught. So here they don't say what is y naught, because usually it may be in billion or million, so we don't care about it, just y naught. So if the rate of growth is proportional to the number of bacteria present. So here, what they are trying to tell, they are telling this differential equation, dy by dt is equal to ky. So that is the definition. That is the differential equation given in sentence form. Determine, it means they are telling us to use this differential equation. Determine the time necessary for the number of bacteria to triple. So triple, what do you mean by triple? Triple means 3 y naught. Okay, so 3 times. So they are asking for the time when y is equal to 3 y naught. So this is the scenario. And what is the differential equation? The dE is dy by dt equal to ky. So already you have some experience in solving or applying the conditions in the differential equation under the heading Newton's law of cooling. The same approach is done here. So first solve the differential equation and take the condition one by one. Even here there will be two constants. That's why we have two conditions, okay, well-known conditions. One is K, that is called the proportionality constant. The another one is after integrating the differential equation, okay. So you will get another constant as C when you integrate the differential equation. So what I am going to do, so separate the variable. So I take y in this side and dt to other side. So what will happen? So dy by y is equal to k dt. So integrate both sides. So you will get ln y equal to kt then plus c. You need the value of y. So we know what we have to do. So take e to the e on both sides. So when you take e on both sides, what you get? You will get y is equal to e power kt then plus c. Okay, which is nothing but y equal to e power kt multiply e power c. So this is the solution of the differential equation, but we have to find what is e power c as well as k. Okay, so take the first condition, t equal to 0, y equal to y naught. First condition. So what is the first condition? T equal to 0, y equal to y naught. So take the above answer, so e power kt times of e power c. So change y as y naught and t as 0, so e power c. So y naught is equal to 1 times of e power c. So you can say e power c is nothing but y naught. So now update. You have to update before going for the next condition. You have to update. So see here. This I am writing here in this place with the update, with the updation. So y is equal to e power c is y naught. So y naught e power kt. So this is the differential equation. This is the answer, not a differential equation. This is the answer after substituting the first condition. Now go to the second condition. Second condition. What is the second condition? The second condition, when t equal to 1, when small t equal to 1, y equal to 1.5, y naught. Okay. So the same condition, when t is equal to 1, y equal to 1.5, y naught. Okay. So now take the function. So y is equal to y naught e power kt. So update y equal to 1.5 y naught is equal to y naught e power k times of 1. So that is the condition. So here I think you can cancel this y naught on both sides. So cancel y naught, and what do you get now is not this color. So 1.5 is equal to e power k. So if you want to find k, apply ln on both sides. So just apply ln. So apply ln and here ln. So what do you get now? You will get k or ln 1.5 is equal to some k. So what is LAN 1.5? Where is the calculator? LAN 1.5. Oh, already there are a lot of numbers. So LAN 1.5. Okay, so what you get? 0.4054. Huh? So 0.4054. So K equal to 0.4054. So always write four decimal places. Huh? So that is better. So now what you have to do? You have to update it again. So update the answer. So update the answer. What is the answer? So y is equal to y naught e power. So we found the value of k, that is 0.4054t. So this is the solution of the given differential equation under the given condition. So really here, this function will tell the number of bacteria present at any time, okay, any time. But what is our task? Our task is to find the time when y is 3 y naught, okay. So that is our task. So to find the time, I can write to find time. So t is equal to what when y equal to 3y naught. So just put the value there like what we did before and simplify and find t. So see here, y is equal to y naught e power 0.4054t. So we know as per the above line, it is y equal to 3y naught. So 3y naught equal to y naught e power 0.4054t. So y naught can be cancelled. Y naught can be cancelled. And what is the remaining? So 3 is equal to e power 0.4054t. Okay, so we need t. Okay, we need the time. So take ln on both sides. So take ln on both sides. So what do you get? In this side, you will get ln 3, which is equal to 0.4054t. So what is t? It is 1 by 0.4054 multiply ln 3. Okay. So use the calculator. Okay, use the calculator. What is the calculator? Ln 3. Where is ln 3? Ln 3 divided by 0.4054. Where it is going? Clear. I write the bracket. Huh? So 1 divided by 0, that is 0.4054, close the bracket, multiply ln, what is that? 3. So what do you get now? You will get 2.7. I can say it is 1. Okay, so 2.71 hours. So when time is 2.71 hours, the number of bacteria will be tripled. Okay, so that is the solution here. I hope that you get the concept here. It is very easy. Okay, so don't think it is very difficult. It is very easy one. So this is the first application. We will go to the second application. I will write in the second page, in the next page, second application. The second application is related to the circuit, okay? It is based on LR circuit. And I will take the question directly because for this it is very easy. Okay, just you have to understand the scenario. So see the question. A LR series circuit is built with inductance 30 henries and resistance 150 ohms and connected to electric supply and connected to a electric supply V of 300 volts. So according to Kirchhoff law of LR series circuit, the governing differential equation is L di by dt then plus Ri equal to V. So determine the flow of current in the circuit when t equal to 10 seconds. So see here, a LR series circuit is built with inductance 30 Henry and resistance 150 ohms and connected to electric circuit of 300 volts. Okay, so here they have we are just building a electronic circuit. Okay, whatever it is. Okay, electric circuit with 300 volts, and here inductance and resistance are connected in series. Okay. Here, don't worry much about the electronics concept, okay? So here, our purpose is to solve the differential equation. So they have given what is R, okay? R stands for resistance, okay? So here R, this is R, capital R, and inductance, okay? That is for L. So they have given the values. Even for V, the voltage is given as 300 volts. Just put in the differential equation, solve the differential equation and find the flow of current in the circuit when t is 10 seconds. So they are asking about the flow of current. Here the current is denoted by small I. Okay, so we will solve the differential equation. Our task is to solve the differential equation. So take the differential equation. What is that? It is, I write in different color. Huh? So it is L di by dt then plus Ri equal to V. So what is given here? The L is 30, okay? The L is 30, it is given here. Inductance, that is 30. So 30, then di by dt, then plus R. What is R? R is given here. What is R? It is 150I. So 150I equal to V. What is V? It is a 300. So it is 300. So I think you can divide the entire differential equation by 30. So divide by 30, divide by 30. So when you divide by 30, what do you get? You will get it divide by 30, divide by 30, divide by 30. So what do you get now? You will get di by dt, then plus 150 by 30, that is 5i equal to 10. So 300 by 30, that is 10. So now we have to solve this differential equation, but it is very easy task, okay? Because just to compare this differential equation with this one, which one? So because we know what is given here is first order linear differential equation, dy by dx, then plus py, which is equal to q. So in the place of y we have I. Okay, in the place of y we have I, and in the place of x we have t. Okay, these are the variables. Okay, so we can solve this differential equation by linear first order method. You know how to start, so you must know what is p. So p is 5. You can see from here p is 5, and what is q? Q is 10. And you know you have to find the integrating factor if, that is e power integral p dt. P dt, usually it is x, okay, but in the place of x we have t. So integral p dt, e power integral, so p is 5, so it is 5 dt. So this is e power integral 5, and it is t, okay. And usually what is the solution we write? We write the solution as y e power integral p dx equal to q e power integral p dx, then dx, then plus c. So this is what we write. But come to our scenario, okay? So our scenario is in the place of y we have I, okay? So in the place of y we have I. So e power integral p d, and in the place of x we have t equal to q e power integral p dt dt, then plus c, okay? So this is the solution. This is the general solution for our case. So here I, that is to be found out, and e power p dt, that is e power 5t, which is equal to q. So q is, you can see there in the top, so it is 10, and e power 5t, and dt, then plus c. So what is I? So I e power 5t is equal to, just integrate, so e power 5t by 5, then plus c, integrate. So I e power 5t equal to, just cancel 5. So what do you get? It is a 2 e power 5t, then plus c. Okay, so this is the solution. But here, to find c, here they don't give any condition, okay? But we can assume some condition. So what you can assume? So see here how I am doing. So we can assume, what we can assume? Assume. What you are going to assume? So initially there is no current in circuit. So circuit. So initially there is no current in circuit. So what do you mean by that? I of 0, that is the current when time is 0. This is time. When the time is 0 is equal to 0. There is no current in the circuit initially. So take the condition. So I of 0 equal to 0. Take this condition. So what is I? So here, what do you mean by this condition? So this condition, t is 0, I is 0. That is the meaning. Okay, so just change it. So here I is 0, e power 5 times of 0, then equal to 2 times of e power 5 times of 0, then plus c. Okay, so here it is 0 equal to 2, then plus c. So which implies c equal to minus 2. So now update. So this will become I e power 5t equal to 2 e power 5t, then minus 2. Our task is to find I. So how can you do that? Just divide both sides by e power 5t. So divide. So if you divide e power 5t, e power 5t, e power 5t. So what do you get now? You will get I is equal to 2 minus 2 by e power 5t after cancelling e power 5t. So what is I? I is equal to 2 minus 2. Take to the top, it is e power minus 5t. But what is our task? You can write this it is nothing but I is nothing but I of t, okay? But what is our task? The task is to find the current in the circuit when t is 10 seconds. Change the time, t is 10. So you will get the answer. So change t as 10. So current in the circuit when t equal to 10 seconds. So put t as 10, 2 minus 2 e power minus 5 times of 10. So this is equal to, just write, this as the answer 2 minus 2 e power minus 50 amperes. That's all. Don't write it too much. This is enough. If you want to use the calculator, you can use it, but it is enough. Okay, so this is the second application. And we go to the third one. The third one is orthogonal trajectories. Even we cannot see much thing, but mathematically, it is very important topic, orthogonal trajectories. Okay. See, first I will give the definition of orthogonal trajectory, then we shall do some questions. Okay. First I will give the definition. So orthogonal trajectory. First I give the definition, after that I will explain it with an example. So any curve which cuts every member of a given family of curves at a constant angle, okay, at the constant angle omega is called an omega trajectory of the family. So first I define what is omega trajectory. Okay, so just to take a family of curves. Family in the sense I already told it involves some arbitrary constant. If you count the number of curves in the family, it means the number of curves in your family is infinite. Okay, so don't forget. So if any curve, okay, any curve is intersecting or uh, cutting every member of the family at some constant angle omega, then it is called omega trajectory. But our concept is orthogonal trajectory. So whenever they use the word orthogonal, don't forget it is they speak about 90 degree. Okay, so orthogonal. So they speak about 90 degree. So what is orthogonal trajectory? So if any curve cuts say a family of curves at right angle, then it is called the orthogonal trajectory. Okay, so I can say yeah 90 degree. In other words, a 90-degree trajectory of the family is commonly called an orthogonal trajectory of the family. So I give some example. After that, you will understand it very clearly. So just a minute. Okay, so see here, what I am trying to tell. So take a family of curves, and if those family is cut by another curve at 90 degree, then it is called orthogonal trajectory. So let us take a family of curves. So let us take a family of curves. What is the family? X square then plus y square equal to c square. So x square plus y square equal to c square. So what is given here? It is nothing but the equation of the circle. Equation of the circle centered at origin. Okay, with radius c. With radius c. Because you might have studied in foundation that, okay, in lower level, I mean. So x minus a whole square then plus y minus b whole square equal to r square. So what is this? This denotes a circle. This denotes a circle with a center. What is the center? AB and radius r. Okay, with radius r. But I don't take this one, okay, because it has some other center AB, but I'm taking here with origin as a center, because the value of A and B is 0 here. And in the place of a radius, I put just some C. If C changes, the radius of the circle changes, automatically you will get different circle. Okay, so let me take the family. So see here how I'm drawing. I put in black. So first one straight line. This is does not look like a straight line. Okay. Okay. So this is XY axis. XY axis. So first I draw a small circle. So see here. It is this one. So this is one circle. Because when you change the value of C, what do you get? You get a different circle. Okay. For example, I put a CS1. When you put a CS1, x square plus y square equal to 1 square. That is the circle of unit radius. X square plus y square equal to 1.01 whole square. It is a circle of radius 1.01. So like that you can change the value of C so that you will get different circle like this. But my circle is not that much good. I am trying to make by using the software. Okay. And like this, okay, whenever you change the value of C, okay, all the circle has the radius, okay, varying radius with the center at origin, because just to see here, they are concentric, okay, they have the common center, okay, they have the common center. Okay, so what I have given here is a family of circles having center at origin. Okay, the question is, okay, how can I ask the question? See, can you find another family of curves such that it will intersect the given family of circles, huh? So a given family of circles at right angles. Right angle. Okay. So the question is, can you find another family? Because what we have family of circles. But can you find another family so that another family cut the given family of circles at right angle? Is that possible? If you ask such a question, yes, it is possible. See here, I'm going to write, okay, I'm going to draw another family of curves, but every member of that family will cut here, every member of the family of circles at right angles. So see here, suppose I am taking the straight lines passing through origin. For example, see here, I am taking a family of straight lines passing through origin. Huh? So, for example, these are the straight lines passing through the origin. Just I am putting as I like. So see here, just I have drawn only few four straight lines. Okay, so well, just see here. Here, these straight lines are intersecting, okay, intersecting the given circle at right angles. Okay, so see here, every point, you can check at every point. So what is the angle between the circle and the straight line? You can say it is 90 degree, okay? They are at 90 degree. So here 90 degree, here 90 degree. Check anywhere. As long as the straight line is passing through the origin, okay, so it is intersecting the family of circles whose center is origin at right angles. Okay, so what I can say here, okay, for the given family of circles, the orthogonal trajectory is the family of straight lines passing through the origin. Okay, so what I am telling, okay, the orthogonal trajectory, okay, I don't like to write. So the orthogonal trajectory of the given family of circles having center at origin is the straight lines passing through the origin. Okay, the straight lines passing through the origin, that's all. But we can do some question, but how to do it? How to do it? So before I'm giving the procedure, just see here, because you have studied from lower level. I put a note. Suppose this is the graph, okay, some curve, and here this is the tangent. The tangent at this point. Suppose the slope of the tangent is m. Okay, the slope of the tangent is m. But if you ask what is the slope of the normal passing through that point, okay, at that point the tangent slope is m. At that point the normal slope. If they ask what is the slope of the normal, the slope of normal. This is the slope of tangent. Huh? Slope of tangent. What is the slope of the tangent here? It is m. What is the slope of the normal? If you know the slope of the tangent, you can write the slope of the tangent as slope of the normal as minus 1 by m, or you can say it is m. You know what is m? M is nothing but dy by dx, or you can write it is nothing but minus dx by dy. Okay, so this concept will be included here. So while writing the steps, you can understand. So see here, the procedure or the steps to solve to find the orthogonal trajectory. The steps to find orthogonal trajectory. So first step, differentiate. So whatever the function they give, differentiate. The second one, replace. Replace c from the given function if it is present. After differentiation, if the arbitrary constant is there, replace from the given function. Don't forget. Then after that, change dy by dx. Okay, because we are going to find another family of curves whose slope will be minus dx by dy. Okay, so if the slope of the current curve is dy by dx, then the orthogonal trajectory slope must be dx by dy with minus. So that is what I have written here. So and that is what here I have written. Okay, if the slope of one curve is dy by dx, if you want to find the slope of another curve which is cutting the given curve at right angle, means it is nothing but minus dx by dy. So that is what I have done here. And separate the variable and integrate. Okay, so these are the steps. We will do one question. So we will do many questions, not one. So we will do some questions. From there you will understand. So find how many questions I have. 1, 2, 3, 1, 2, 3, 4, 5 questions I have. I will do all the questions because we have only standard types of question. So I will do all the questions so that you will get the clear idea. Find the orthogonal trajectory for all lines passing through the origin. So here they don't say uh, they don't give any equation. So but they have given in sentence very clearly. Find the orthogonal trajectory for all straight lines passing through the origin. But we know the answer. Just now we discussed uh, if you take a family of straight lines passing through the origin, then if you want to find another family which is cutting the given straight line in right angle, means it must be circle. Okay, but that is what we are going to prove. So first you must know what is the equation of straight line or the family of straight line passing through origins. So the equation for the family of a straight lines passing through the origin, passing through the origin is given by y equal to cx. Y equal to cx. In lower classes, you studied y equal to mx plus p, mx plus c, not b, mx plus c. So this is the equation of a straight line, okay, and having the slope m with intercept, okay, with y-intercept at c. Okay, so This is what we do. But if I make a C as 0, okay, what do you get if you make C as 0? Y equal to mx. But in the place of m, I put a C here. That's all. So if you want to find, if you want to know the equation of straight line, the general form of equation of straight line, that is y equal to mx. But here I have written y as cx. Okay, so see the first step. Differentiate the first step. It's very simple. The first step, differentiate. What when you differentiate, what you get? Dy by dx is equal to c. That's all. And c, the second step, replace c from the given function if it is present. See here, in this place there is c. Some question you will not find c, but here we have c. If c is present, you have to find the value of c from the given equation. So take the equation. What is c from here? C is equal to y by x. Y by x is equal to c. Okay, so I need c. So take x to other side. So y by x is equal to c. So see the situation. So dy by dx. Now I need the value of c. What is c? It is y by x. Okay, so go to the third step. What is the third step? Change dy by dx by minus dx by dy. So see the third step. So it is minus dx by dy, okay, equal to y by x. So only this side I am changing. Only this side I am changing. So dy by dx is equal to minus dx by dy. Okay, so now you have to separate the variable. That is what I have written as the last step. Separate the variable and integrate. That will give the answer. So separate the variable. So separate the variable. Even I can remove this. So separate the variable. So take this x this side and dy here, and what you get now. So it is the fourth step. So minus x dx equal to y dy. So integrate. Just put the integral symbol. So integrate. You will get minus x square by 2 equal to y square by 2. And here you can put a c on any side. I'm just using c on this side for our comfortability. So I put a c now. So simplify this. So take this term to other side. What do you get now? You will get c equal to y square by 2, then plus x square by 2. So take so c is equal to y square then plus x square by 2. So just cross multiply this 2. So 2c equal to y square then plus x square. I can write x square then plus y square equal to some c1. So what is given here? This is the orthogonal trajectory. Don't forget, this answer is called the orthogonal trajectory. Orthogonal trajectory. So really what this equation denoting, this denotes the family of circles passing through the origin. So that is what I have explained in the beginning. Okay, so x square plus y square equal to c1. See here what I have written, x square plus see here what I have written here, x square plus y square equal to c1 square. But here I have written as c1, but it can be written in that way. Okay, c1, okay, the root of c1 whole square. You can write in this way, x square plus y square equal to root of c1 whole square. So it is taking the form x square plus y square equal to c square, something like this. So in this way you have to do it. So take the next question. The second question in this orthogonal trajectory. Find the orthogonal trajectory of the family of parabolas y square equal to cx. Okay, so the same procedure, huh? First differentiate. If c is present, replace it. So differentiate. So differentiate the derivative of y square. The derivative of y square is 2y dy by dx. Huh? Don't forget. So this is equal to the derivative of x is 1. So what do you get? 2y dy by dx is equal to you must replace c with some equivalent thing. Okay, so what is c from here? So y square by x is equal to c. Okay, so what is the c? Y square by x. So that is what I have done. After that, what you have to do? You have to change dy by dx as minus dx by dy. Don't forget. So this is equal to y square by x. So separate the variable and check what is possible. If there is anything to cancel it before integrating both sides. So see this minus x dx is equal to y square dy by 2y. So that is what you get when you separate the variable. So here you can see something can be cancelled. I can say this y square, one y square can be cancelled. I write without anything, without cancelling that. So x dx is equal to y, okay, y by 2, y by 2 dy, y by 2 dy after cancelling one y. So now integrate, just integrate both sides. So integrate here. So it is minus x square by 2 equal to, and here 1 by 2, take it outside, and it is a y square by 2. Then plus c. You can write plus c here. So that is better. Why I am writing this side? Because then you will avoid the confusion. So plus c here. It is better to write any side wherever you feel comfortable. So now take to this side. What do you get now? You will get something like this. So y square by 4 then plus x square by 2 is equal to c. That's all. This is the answer. If you want to simplify, you can simplify, but no need. Just it is the orthogonal trajectory. So orthogonal trajectory. So this is the second question. Very simple, very easy also. See the third question. The last question will be lengthy. So find the orthogonal trajectory of the family of curves xy equal to c. So find the orthogonal trajectory of the for the family of curves, of the family of curves xy equal to c. So see here, here xy is equal to c. So if you want to differentiate, you have to use the product rule. Don't forget. So this is like u and this is like v. So uv dash then plus vu dash. That you have to do it. So if you want to differentiate. So differentiate, see different types of questions are there. So these are the standard question. So differentiate. So when you differentiate, what do you get? It is x y dash then plus y x dash is equal to 0. So what is that? It is x dy by dx then plus y times of 1 equal to 0. So x dy by dx then plus y is equal to 0. Okay. See in this question, you don't find any arbitrary constant. But see the previous question. In the previous question, after differentiating, we found some constant. After that, we changed that constant by using the equivalent expression. Even the first question, after differentiating, we found some constant. But in this last question, okay, in this third question, you don't find any constant after differentiating. Then the task is very simple. So now what you have to do? So change dy by dx as minus dx by dy. Okay, then plus y is equal to 0. So minus x dy dx by dy is equal to minus y. So take that side. Take y to other side. Minus y. So cross multiply. Just take dy to other side. So what do you get now? It is minus dx. Minus x dx is equal to minus y dy. So integrate both sides now because the variables are separated. So minus x squared by 2 equal to minus y squared by 2. Then even here you can put a c here in this side. Okay, but wherever you want you can keep it. Just for our convenience I am keeping on this side. So take this term to other side. So c is equal to y squared by 2 minus then plus x squared by 2. Or you can write x squared by 2 minus y squared by 2 equal to some c. If you want to x squared minus y squared by 2 is equal to some c. X square minus y square equal to 2c. X square minus y square equal to some c1. That's all. Okay, you can stop here itself. You can stop here itself if you want. Okay, if you want to put a clear, very clear answer, you can write these steps. But these steps are optional. If you want, write. Otherwise, no need. So this is the orthogonal trajectory. Is the orthogonal trajectory. So this is the third question. So the fourth question. So what is the fourth question? The fifth question is a little bit lengthy because that will come under the homogeneous differential equation. Okay, so find the family of orthogonal trajectories for the circles x square plus y square equal to c. Okay, I think a 4 question is enough, but if time permits, I will do the last one. Okay, so take the given equation x square plus y square equal to c. So differentiate both sides. The same story. Differentiate both sides. So the derivative of x square is 2x. The derivative of y square is 2y dy by dx equal to 0. Here also there is nothing to be replaced because there is no c. Okay, so 2y dy by dx is equal to minus 2x. So I think you can cancel this 2. So y dy by dx is equal to minus x. So cross multiply this dx. So y dy is equal to minus x dx. So integrate. So if you integrate, what do you get? If you integrate, okay, if you integrate, what do you get? 2y by dy. See, I did not change that, because that's why I get a wrong answer. So don't forget here, after cancelling 2, what you get? You get y dy by dx is equal to minus x. Huh? Don't forget that step because we are trying to find the orthogonal trajectory. If you without changing dy by dx as minus dx by dy, again you will get the given equation. Don't forget, huh? So I'm going to change this part. So y, what is that? I'm writing in different color so that you will not miss this step. Minus dx by dy, then equal minus x. So what do you get now? It is minus y dx by dy is equal to minus x. Okay. So what you can do now, so cancel that minus. That is better first. So cancel that minus. So it is dx y dx by dy equal to some x. So what you can do now, take this part, this entire part to other side and bring this x down. So dx by x is equal to dy by y. Okay, now integrate. Now integrate to both sides. So what do you get? You get ln x equal to ln y, then plus right ln c, because c is constant, ln c is also constant. Okay. Just for our if you don't want to, you can write as you like. Huh? So I have to confuse you because it is normal to say just ln c. So write c, no problem. After that, take this ln x or ln y to other side. Okay, or I can do one thing. Why I have to add c on that side? Why not this side? Because that will avoid some confusion. So take this ln x to other side. So what do you get? C is equal to ln y minus ln c, ln x. So c is equal to, by using the property of logarithm, it is ln y by x. Okay. And what do you get now? So take e to the power on both sides. So e power c is equal to some y by x. So what is e power c? Some c1. c1 equal to y by x. So what is y? c1x. So what is this? This is the orthogonal trajectory. But what is the nature of this? So this is the orthogonal trajectory. But what is this? This is nothing but the family of straight lines passing through origin. So the family of, I can write, the family of straight lines passing through the origin. Okay, so it is of the form y equal to c1x. Okay, so this is the answer for this question. There is one more question, but it is a little bit lengthy, but okay, I will do it. What else we can do? The fifth one, find the orthogonal trajectories of to the family of curve x square plus y square then plus cx plus cx is equal to 0. Okay, so this is the question answer. You know what you have to do, just to take the function one more time. Given family, even I can write given family. What is the given family? X square plus y square plus cx is equal to 0. So differentiate. So when you differentiate, what do you get? You will get the derivative of x square, that is 2x, the derivative of y square, that is 2y, dy by dx. Then the derivative of cx, that is just c, is equal to 0. Okay, so yeah, after differentiating, we have C here. So you have to find C from the question. So what is C from the question? X square plus y square, then plus CX is equal to 0. So x square plus y square equal to minus CX. So what is C? I can say C is equal to x square plus y square by minus x. Okay, so from here. So put the value in this place. So what do you get now? So it is a 2x plus a 2y dy by dx. Then plus, in the place of c, I am putting x square plus y square divided by minus x is equal to 0. So I can write in a more clear way. So 2x then plus 2y dy by dx minus, so bring that minus in the front. So x square then plus y square divided by x equal to, okay, equal to 0. Now what I can do, multiply every term by x, so that I can remove that x in the denominator. So multiply x on both sides. So multiply x, multiply x, multiply x. So if you multiply x, here you can cancel that x. So what do you get when you multiply x on both sides? You get 2x square, then 2xy dy by dx minus x square plus y square equal to 0. Okay, so this is what you get now. Now what can I do? Just to see what I'm doing. So 2x square then plus a 2xy dy by dx is equal to, so take this term to other side. So when you take to other side, what do you get now? You will get x square plus y square. So after that, don't forget, there is one more 2x square. So take to other side. So what do you get now? It is 2xy dy by dx is equal to x square plus y square, then minus 2x square. So 2xy dy by dx is equal to y square minus x square. So just to simplify. So what is dy by dx? So dy by dx is equal to y square minus x square by 2xy. So this is the differential equation, okay, uh, derived out of it, and we are planning to find the orthogonal trajectory. And don't forget, when you want to find the orthogonal trajectory, that dy by dx must be replaced by minus dx by dy equal to y square minus x square divided by 2xy. Okay, so see this. By using this minus, just this minus, and there is minus here. So by using this minus, what I am doing now, see here. So dx by dy is equal to x square minus y square by 2xy. Okay, so just multiplying minus inside here in this side. So this will come in this side, and this y square will come this side. Okay, that is what I have written here. So y square, x square minus y square divided by 2xy. Okay, but just take the reciprocate both sides. When you reciprocate, okay, take upside down on both sides. Okay, so what do you get now? Dy by dx is equal to 2xy divided by x square minus y square. So this is the differential equation we get, okay, and we have to solve this to get the orthogonal trajectory. But see this, what is given here is a homogeneous differential equation. Homogeneous differential equation. And you know the rule, when you see homogeneous differential equation, y equal to vx, dy by dx is equal to v plus x dv by dx. You know all these stories. Okay, so let us start. Okay, so what is the dy by dx? It is v plus x dv by dx is equal to 2 times of x, and y is vx divided by x square minus vx whole square. So simplify this. V plus x dv by dx is equal to 2vx square divided by x square, then minus v square x square. So take x square outside. So 2v x square divided by x square. When you take, it is 1 minus v square. So x square and x square get cancelled. Huh? So what is the remaining? It is v, then plus x dv by dx is equal to 2v by 1 minus v square. So v. So take v to other side. What do you get now? It is x dv by dx is equal to 2v by 1 minus v square minus v. But v is nothing but v by 1. So cross multiply now. So when you cross multiply, what do you get? It is x dv by dx is equal to 2v times of 1 minus v times of 1 minus v square divided by 1 minus v square multiply 1. So that is what you get. So simplify this. So what do you get now? You will get x dv by dx equal to 2v minus v, then plus v power 3 divided by 1 minus v power 2. So here in the numerator we can cancel 1v. So x dv by dx is equal to v plus v power 3 divided by 1 minus v square. Okay, so now you know what to do. Just take this part to this side and this part to this side. So what do you get now? This everything will go upside down. So it is 1 minus v square by v plus v power 3 equal to, the dv, dv and dx by x. So you have to integrate both sides. Okay, here solving by partial fraction method, it will work, but I will tell you a shortcut. So I'm going to integrate both sides. So integrating, so 1 minus v square. So this minus v square can be written as v square minus 2v square. In the denominator, okay, in the denominator, v plus v power 3. What is that? Take v outside, it is 1 plus v square. So in the denominator, I can write it is v 1 plus v square. And here dv. And here it is 1 by x dx. Okay. So if you combine these, v square minus 2v square, that is minus v square. That you will get. V square minus 2v square. So now I am going to separate term by term to reach the answer. So it is 1 plus v square by v 1 plus v square minus 2v square divided by v 1 plus v square dv equal to integral 1 by x dx. So see the first term. Here you can cancel. Just I am separating term by term. Okay, this part is 1. This part is 1. And another part is 1. Okay, like this I am separating. So here you can cancel this 1 plus v square. So what do you get? And here you can cancel only 1v. So what do you get now? Here it is 1 by v minus 2v by 1 plus v square dv equal to integral 1 by x dx. So the integral of first one is ln v minus the integral of the second one is ln 1 plus v square, because the derivative of the numerator is the derivative of the denominator is in numerator. When you differentiate 1 plus v square, it is 2v. Okay, so the ln of 1 plus v square equal to, it is ln x then plus c. And you know what is v? The v is y by x. 1 plus y by x whole square equal to ln x then plus c. So that's all. This is the required orthogonal trajectory. That's all.